Okay, so we're gonna do notes a little different today. I'm gonna apologize now if I start coughing because I am not feeling well. So I'm gonna try to get through these as quickly as possible. So our essential question is, how can you translate and reflect a figure in a coordinate plane? So we're gonna be translating. So we're going to translate and reflect. All right, so we're going to perform translations and reflections. We're gonna perform compositions, identify lines of symmetry, and we're going to solve some real world problems. So the first thing, what is transformation? Transformation is a function that's going to move or change your figure in some way to produce a new figure that is called the image. Another name for the original is your pre-image. The way I've been explaining it is the pre-image would be the original. So for example, if someone's going to take a picture of you, you would be the pre-image and the photograph is the image. Okay, so the points on the pre-image are the inputs. The points on the image are your outputs. So let's do some of this. So the first thing we're going to do is a translation. So notice that to do a translation, this is your notation. So you're going to take your x and your y and you're going to do something to the x. You're going to do something to the y. In here, plus 7 means 7 units to the right. Minus 3 means 3 units down because the x goes left and right. The y goes up and down. So in these two exercises, we're going to do the same translation. So we're going to add 6 to the x's. So if I add 6 here, I get that 4 plus 6 is 10, and it says to subtract 3 from the y, so I'm going to subtract 3. So 5 minus 3 is 2. So J was my pre-image. J prime is the image. Okay, on the second one, it's already a prime, so it's already R prime, so we're going to find R double prime, which means that we are going to see what happened after it's been moved once already. So we're going to add 6, so 0 plus 6 is 6. And we're going to subtract 3. Negative 5 minus 3 is negative 8. So our double prime is located at 6, negative 8. All right, so let's write a rule. So sometimes you'll be given two figures and they'll want to know what the rule is. So you can pick any point. I'm going to choose Q and Q prime. So I'm going to find where Q is located. So Q is at 1, 2, 1, 2, 3, 4, 5. So it's negative 2, 5. Q prime is located at negative 1, 2. So basically what I need to do is figure out, well, what happened? How did I go from negative 2 to negative 1? So if I was at negative 2 and went to negative 1, I added 1. And to go from 5 to 2, I had to subtract 3. So the rule is to add 1 to my x's and subtract 3 from the y's. So this would be your rule. This would be your translation. All right. So we're going to graph these points. So 2, 2 would be here. So here's R. 5, 2, 5, 2. So here's S. And 3, 5. 3, 5 is here. So that is my T. So I have this triangle. And they want me to translate the pre-image by adding 1 to all of the x's. So if I add 1 to all of the x values, I can get R prime, S prime, and T prime. So R prime, so 2 plus 1 is 3, 5 plus 1 is 6, 3 plus 1 is 4. So there are my new x values. And to add 2 to the y values, so I'm going to add 2 to all of my y values. So 2 plus 2 is 4. 2 plus 2 is 4, and 5 plus 2 is 7. So here are my new points. So if I plot them, so 3, 1, 2, 3, 4. So there is R prime. 6, 4. So there is S prime. And 4, 7, 4, 7. There's T prime. So here is my new triangle translated. All right, so to do a reflection is just a flip. It's a mirror image. The goal is to make sure you always stay the same distance away from the line you're reflecting over at all times. So if I want to make sure I'm staying the same distance away at all times. So I'm going to plot these points. So I've got 1, 3, 1, 3. So there's J. 4, 4. There is K. And 3, 1 is L. So here is J, K, and L. They want me to reflect over the x-axis. So that means I'm going to go from here to here because I'm reflecting over the x-axis. So if we were to highlight, so let's do a highlighter. So we're going to reflect over this axis here. All right. So let's go back. So since I am 1 unit away, I need to remain 1 unit away because that's the whole goal. So that would be L prime. So notice if I keep up with this, L prime is located at 1, 2, 3, negative 1. So 3, negative 1. Well, if you compare it to the original, notice the only thing that changed was the y value. So let's see, what would K prime be? So 1, 2, 3, 4, 1, 2, 3, 4. So where's the location of K? So K prime is now at 4, negative 4. And again, if I compare it to the original, the only thing that changed was the y. So J prime, well, that's 1, 2, 3, 1, 2, 3. So J prime would be here, so that would be 1, negative 3. And again, if you compare it, the only thing that happened was the y changed. So if you take a point AB and you reflect it over the x-axis, the new point is the x value stays the same, the y value is opposite. So if we do the same thing over here, same point. So we've got 1, 3, so 1, 1, 2, 3, 4, 4, and 3, 1. So now we've got this one. This time we're going to reflect over the y. So we're going to go this way. So this time we want to stay the same distance from y. So if I'm 1 unit away, I want to stay 1 unit away. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. So there is K prime and L prime. So maintain equal distance. So now J prime is at negative 1, 3. K prime is at negative 4, 4. And L prime is at negative 3, 1. So if you compare these to the originals, notice that the y values all stayed the same and the x values became opposite. So the rule, if your A and B is reflected over the y-axis, then you get negative A, B. So if you reflect over the x, x stays the same. If you reflect over the y, y stays the same. But what happens when you're going to reflect over the parent function of y equals x? So I want to reflect over y equals x. So this is going to be, I'm going to reflect over this line right here. So this is my line of y equals x. So y equals x. The easiest way to do these is if you will pick a point, and what you want to do is you want to draw a horizontal line from that point to this. Oh, that is way too big. Let's get rid of that one. I don't like that one. Delete. Okay, so we're going to draw a horizontal line. So from your point to the line, then draw a vertical line from the point to the line. And then basically all you're going to do is finish off the box so that it's like this. And that final point here is where you end up. So if that was point C that I drew from, this is going to be C prime. So C prime is located at 1, 2, 3, 4, negative 1. Well, where is C? Well, C is at negative 1, 1, 2, 3, 4. Negative 1 of 4. So notice what happened here is they just switched places. And that's the rule. When you reflect over the parent function, the a and the b or the x and the y, they just trade places. That's all that happens. They just trade places. All right. So what happens now when I'm going to reflect over the negative parent? So now I've got this one. So now I want to reflect over this line. So now I'm going to go over here. And I'm just going to pick a point. So let's just choose point B. So if I'm going to reflect over point B, I'm going to draw my little line. So from B straight down, from B straight across, and then I want to finish it. So you always want to finish your little box. So this would be my point. So B is located at, and notice these are counting by twos, 4, 5, 1, 2, 3. So B is at 5, 3, where your B prime is at 1, 2, 3, 1, 2, 3, 4, 5. So it's at negative 3, negative 5. So now you'll notice they switched places and became opposite. So now it's going to be negative B, negative A. So over the parent, they switch. Over the negative parent, they switch and become opposite. So they're opposite switch. Okay. And then, of course, you may not always be flipping over just a line that's the XY axis or the parent function. Sometimes you may actually be flipping over an actual line. So, for example, x equals negative 1. So I go to the negative 1, and I want to draw a line that goes through negative 1. So now, if I plot these points, 1, 3, so 1, 1, 2, 3. B is at 5, 2, and 2, 1 is my point C. So now what I want to do is I want to flip. So I want to flip over this. So I am 2 units away, so I need to be 2 units away. So there's A prime. B is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So B prime would be out here somewhere. C is 1, 2, 3, 1, 2, 3. So there's C prime. So now let's see if we can find out what happened. So if A is there, so we've got A is at 1, 3. Then A prime is at, so this is 1, 2, 3. So it's negative 3, 3. So negative 3, 3. So basically, we just looked and we're like, okay, we were 1, 2 away, so we doubled it. So you double however far you are. So B is located at 5, 2. So we said B was 1, 2, 3, 4, 5, 6. So we went 6 backwards, so let's go 12 backwards. So negative 7, 2 is where B prime is at. C is at 2, 1. So 2, 1. So how far is C? Well, 1, 2, 3, double it. So it's 6 away. So we're 6 away. So that's negative 4, 1. And there's your C prime. Same thing's going to work when you flip over a horizontal line of some sort. So y equals 1. So there's y equals 1. We'll plot the same point. So 1, 3, 5, 2, and 2, 1. Okay, in this case, point C is already on the line. So when I reflect this way, C is going to stay the same. C will not change. C will, I don't know why that's, all right, let's try this again. C will not change because it's on the line of reflection. So it's not going to change. So A is at 1, 3, and B is at 5, 2. All right, so let's find A prime and let's find B prime. All right, so since this is 1, 2, so 1, 2, so it's going to be right here. So that's at negative 1, 1, negative 1, 1. So since I went down 2, then I got to go down 4, so you're subtracting 4. Where this one over here, B, is 1 unit away, so it's going to be simply 1 unit away. So that means subtract 2, so 5, 0. So that's where your new one will be. So this is B prime, and this is A prime, and the C didn't change, so it looks more like that. Okay, a rigid motion is a transformation that preserves. So this one, I'm going to type this up. So this is going to preserve length and angle measure. So it's going to preserve, and let me make this a little bit smaller. Maybe not. Length and angle measure. So it is a transformation that will preserve length and angle measure. It is also called an, well, I don't know what is going on here. All right, it's not going to let me do anything now. All right, so it's also going to be called an isometry. So let's, I guess it's going to freeze up. Not cool. So it's also called an isometry. Sorry about that. It's an isometry, and it's also called a congruence transformation. Meaning that everything stays the same. So obviously, if the length and the angle measure stay the same, and it's called a congruence transformation, that just means that your shapes are all congruent. So same shape, same size. So nothing changed. And then, of course, our last part, composite transformation. So a composite transformation is basically doing two translations or two transformations, not just one. So we're going to graph the points R and S. So point R is at negative 2, 5. So there's point R. And negative 4, 1. So there's point S. And they want me to add 5 to both. So if I add 5 to both of these, and then subtract 2 from both of these, so negative 2 plus 5, so I need R prime and S prime. So 2 minus negative 2 plus 5 is 3. 5 minus 2 is 3. Negative 4 plus 5 is 1. 1 minus 2 is negative 1. So there's where my next point will be located. So 3, 3. So there's R prime. And 1, negative 1. There's S prime. So there's your first translation. And now to this point, you're going to subtract 4 from the x's and subtract 2 more from the y's. So now I've got R double prime and S double prime. So 3 minus 4 and 3 minus 2. 1 minus 4, negative 1 minus 2. So now I've got negative 1, 1. So there's my R prime. And negative 3, 1, 2, 3, negative 3. There's my S prime. So there are your 3. So you got your pre-image, your image, and your image. Okay, what about reflecting a triangle? So we've got 3, 2. So 3, 2, 5, 4, and 2, 4. So we'll put point A here. Let's erase. All right, so now we've got triangle ABC. And first thing we want to do is translate. So A prime, B prime, C prime. So it says to subtract 6. So 3 minus 6 is -3, and it doesn't say to change the y. Keep it. Subtract 6. 5 minus 6, keep the y. 2 minus 6, keep the y. So now here are my new points. So my new points are -3, 2, -1, 4, and -4, 4. So now here's ABC. So A prime, B prime, C prime. Then it says reflect over the x. Remember when we reflect over the x, x stays the same. So now I've got double prime, double prime, double prime. So I'm going to reflect over the x-axis. So if I'm reflecting over the x-axis, x stays the same. So I'm going to write all my x values because they're going to stay the same. And then remember the y values just become opposites. So -2, -4, -4. So now I've got -3, -2, -1, -4, and -4, -4. And there is my final destination. So we slid it over and then we flipped it over. All right, so lines of symmetry are basically how many lines do we have that will allow you to cut this thing. So I want it to be cut evenly, so I can flip it there. This point matches with this one, and then I can cut through here. So this one has 2 lines of symmetry, where this one over here, well, I can go this way and this way again, but then I can also go this way, and then I can also go through these 2 corners and these 2 corners. So this one has 6 lines of symmetry, where this one over here only has 1. And last but not least, in a video game, you want to move a spaceship 1 unit to the left. So if I want to use the spaceship 1 unit to the left, but 4 units up, so 1 left, 1, 2, 3, 4 units up. So I'll call this point A, so this would be A prime. And then you would do that to all of them. But then it wants you to take this and then move it 2 units to the left. So now I want to move it to here. So that would be 2 units to the left. Write this as a single composition. So we just want to write it as 1. So let's go here. So the first thing I want to do is I want to take the x and the y. And the first thing it said to do was 1 unit to the left, so x minus 1, and 4 units up. So that's what it told me. Then it said, then take this and go 2 units to the left, but leave the y alone. So x minus 3, y plus 4 would have been our rule that we would have needed to move this in 1 single movement instead of 2. See y'all later. We'll do the backside in class.